very good morning to Dr. Omar and all my fellow friends. So we are Group 5. Today we are going to do a simple experiment about it's called the simple electric motor, which is also called a monopolar motor. So it simply use a battery, a magnet, and also a copper wire which is refined by the sandpaper. So it will create a magnetic. So it uses a battery, a magnet, and also a copper wire which is being refined by the sandpaper. So it is being shaped to the shape like this, then put it on the device, then it will spin due to the electricity and also the magnetism. So this experiment is using the Fleming's left hand rule, right hand rule, and also the Lorentz force. So all of these theories or application. So actually this experiment, this principle is the principle of all electronics motor. So for example, like the application nowadays is very popular, like electrical cars, like Teslas. All of them are using these applications, and even though not like electrical cars, the fans, air conditioners, washing machines, drones, industrial machines, all are using these principles for the application.
Hi, my name is Leiu Zhong Han from Group 5, and I'll be explaining about the right-hand rule part of our experiment. First, at point B, the current is flowing in the negative y direction, and for the magnetic field, it's flowing in the negative x direction. Using the right-hand rule, what we need to do is pointing our thumb in the direction of the current and our forefingers in the direction of the magnetic field. And for now, our palm will be facing into the page. And that's where the magnetic field will be coming out. In this case, to represent that, we're going to use a circle with an X along this wire. And if we follow the same process on the left side, the magnetic field is going into the page, which means the left side is turning in this direction, which is also clockwise direction.
Okay, since we have a formula which is the F equal to ILB sin theta, we have a magnetic force which is equal to the current I, length L, and also the B, magnetic field. So from both forts, we can have the four factors, which is we can increase the speed of the coil, which is the first of all the current, where we use the performance of the battery that can apply the more release current from the battery, the more increasing of the current, and the more increasing speed of the coil. Next, for the magnetic field, which is we can increase the numbers of the magnets that can also increase the speed of the coil. And lastly, also the length of the coil that can make the speed of the coil increasing, which is when we use the increasing of the length, we can increase the magnetic field of we can increase the magnetic force of the experiment. So the closer of the coil, which is the magnets, the frequency or the magnetic field is increased, which is will make the magnetic field more stronger and will make the increasing of the magnetic flux. So that's all from us. Thank you.